Hello, I'm Amy Rose. We are ready for the next part now. In the second case, let's talk about cubic closed packing, CCP. As before, Sonic the Hedgehog learned us in terms of mathematics. Cubic closed packing are known to be the densest possible packings of equal spheres. Simple cubic packing consists of placing spheres centered on integer coordinates in Cartesian space. Let us suppose 3 atoms are touching the surface one after the other. Can you believe how does the shape form? It can therefore form an equilateral triangle, or tetrahedron, or double tetrahedron in shape. You know, each equilateral triangle is formed when all angles are 60 degrees. Tetrahedron, that will have 4 equal faces of equilateral triangle. The central part of tetrahedron is found to be here, like the tetrahedral molecule CH4, that is, a carbon atom. You should keep in mind that the angle between 2 bonds is 109.5 degrees. Similarly, you can try making octahedron as well. You will notice a square can be seen in 3 ways. Next, the face-centered cubic FCC has a coordination number of 12 and contains 4 atoms per unit cell. As it is similar to the first case, just like we taught about BCC against Sonic. For example, sodium chloride, NaCl, 8 chlorine atoms are at the corners, and 6 chlorine atoms are in the central face of a cube. Also, 12 sodium atoms are at the edges of the cube. And finally, hexagonal closed packing, HCP, is a coordination number of 12 and contains 6 atoms per unit cell. Just like we've learned for the cubic closed packing structures. Consider 7 atoms, 1 atom is the central part, and other 6 atoms can touch each other. This is an equal hexagon, with 6 equilateral triangles. So, you know, if you cut the atoms into pieces, you can find out, in the form of a square and equilateral triangle. In terms of area you can find out, least will have a difference for lattice spherical spaces. I hope you've learned about hexagonal closed packing structures. Like, comment, and subscribe now.